Hello, welcome to the industrial classroom. After so much of a long time, we have finally come back with a new topic, that is the gear and gearboxes. And believe me, this will be a very interesting topic. We have come with some animated videos, and you will get to know some of the most important things. So now, before moving on to the gearboxes, let us first know what are these drives. When we come to drive, we know that drive is any mechanism which is used to transmit power or motion from one shaft to another. For example, there are two shafts. Okay, let me take, this is one shaft and this is the second shaft. For whenever we are talking about drives, we know that the motion of the one will create motion of the second, or the power will be transmitted from 1 to 2 or from 2 to 1. This is the first mechanism. Next, it is used to transfer rotational motion, speed and torque. Remember, this is about drives and not only gear. Gear is a part of drive. Okay. Now, drives are essential components of machine and industrial systems. Not only machines, whenever you are watching some moving machinery, moving things, like when you are watching a clock, there is the hour clock, the second clock, these are all moving. So these won't be possible without the drives, because movement of one causes the movement of other. So the main thing here is the transmission of power, transmission of motion, of rotational speed, of torque. Now let us move to the second slide, that is the function of a drive. First thing we learned that there is transmission of mechanical power. Second, there is change in speed ratio. We will learn about this in the later part, what is speed ratio. Next, there is a change in direction of motion. Okay, for example, you are riding on a bicycle. Okay, you are pedaling the wheel, due to which what happens, the chain connects with the another wheel. Okay, this is about a bicycle. Okay, so it is connected to a chain. So the motion of this pedal, or the of this pedal, it transmits power, due to which this wheel also rotates, and also causes rotation of the front wheel. Okay, so from where does this start? It starts from the motion of your legs. With your legs, you provide it a circular motion, due to which the chain drive, here this is the chain drive. Okay, this is the drive which is used to transmit power from the first axle to the second axle, right? So this is the drive. It transmits power, it changes the speed ratio. Okay, next it changes the direction of the motion. In many cases you will see that in gear drives you will see how it changes the direction of motion, and it increases or decreases the torque. We know that whenever the speed increases, the torque reduces. So whenever the speed decreases, the torque reduces, the torque increases. So it is vice versa. Okay, so it is vice versa. Speed is inversely proportional to torque. Remember it, this is a very important thing, because whenever gears are used, we will see that how on decreasing the speed, we will increase the torque. Now the fifth function of the drive is it connects shafts at different distances. So in this case, in the cycle, you can see how long distances are covered by this chain drive. Okay, so next we know in conveyor belts there is a drive, a drive, the belt drive. Okay, now let us move to the types of drives. First is the belt drives, a very big example of the conveyor belts. And then we see in machine tools also we can find the transmission of the power, or the reduction of the RPM, the speed. Okay, in V belts, in machine tools you can find in your workshop, in older machines, right? Next, chain drive. This is an example of what we learned previously in the bicycles. Next, in rope drive, you can find it in the hoists, in the cranes, in sieve pulleys. Okay, so these are all examples. These are wire ropes. Okay, not the ropes which we are, fabric ropes which we are using, but these are wire ropes. We will cover some lesson about the wire ropes also in some later modules, means some other day. Next, gear drives. This is a very common example of the gear drives, right? So finally, we come to the gear drive. We have learned what is drive, what is the function of the drive, and what are the most common types of drives. Now, the first thing is gear drives. So before moving on to the gear drives, why do we need this gear drive? First, all of the example, we have belt drive, we have rope drive. Okay, then why do you need another type of drive? Gear drive. You know that it is a construction of it is very difficult, and then why do we need it? See, whenever we use the belt drive, rope drive, there is chances of slippage. Okay. For example, you want something with precision, a very precision thing. You have used a belt drive and you wanted that after one rotation it should stop. It is very difficult. It's very difficult because there is rope extension, there is friction, there is slippage. All these tend to make it less precise. Therefore, whenever it comes to accuracy, whenever it comes to efficiency, whenever it comes to transmission of larger amount of power, we use gear drive. And it is most suitable for short distances. For long distances, we can use some idler gear in between. Okay, if these are two gears, then in between we can use some idler gear 1, 2, 3, 4, 5, 6. But finally, it is a very means it's not useful. Okay, we can get the motion, but it's not recommended to use so many idler gears, because there will be a large number of moving machinery, there will be a large number of feed generation. Okay, next, the advantages. First, see, it is of high efficiency. There is no slipping. We know that whenever we have a gear like this, let us make a gear like this. The tooths of the gear and the pinion. Okay, so these are tooths. These tooths interlock each other. It interlocks with each other, and due to which there is a positive drive. So there is no slipping. Hence, it is called a positive drive. Okay. Next, it is of compact size and its speed ratio is very precise. Okay. Then it is very suitable for heavy load. We will learn about the speed ratio. Okay. Very suitable for heavy loads. It can transmit a large load of power, a large load. Then what are the disadvantages? High initial cost. It requires precise alignment. High initial cost because manufacturing cost is very high. The metal cost is also high. And noisy at high speeds, since there is a lot of engagement in it, and both of these are metals, or we can say there are also plastics here used, but engagement, disengagement regularly, it creates high noise. Then manufacturing is difficult. Next, where are these used? If we see in industries, you can find it in automobile gearboxes, machine tools, clocks and watches, industrial reducer, robotics and automation system. If you have a damaged watch, you can just open it and see how the gear mechanism inside it works. There's so many lots of gears here, starting from the movement of a simple motor to the first gear, then second, pinion, third, fourth, and these all are connected in such a way it moves the hour, it moves the second arm, it moves the minute arm. Now let us come to a very tabular view of the drives. First we'll see here this is the belt drive. Its efficiency is medium due to slippage. And its cost is very low. Does it face slippage? Yes, and load capacity is light. When we come to chain drive, its efficiency is high, cost is medium. There is no slippage here. Load capacity is also medium. In rope drive, we see medium efficiency. Whenever we see there is slippage, we will find that the efficiency will be low. For example, here slippage. See the efficiency here, it is low. Next, cost of the rope is high because there are twinning structures, intertwined structures. It is very difficult. Next, load capacity is heavy. Friction. What happens in the friction drive is that two wheels, suppose, are friction. By friction they are moving. Okay, they are in contact with each other and moving. There are no teeth here, but with friction. So in friction we can say that there is a little rugged surface. These are not gears, right? These are some rough surface due to which friction drives. Next is cost is low, slipping and load capacity. In gear, it is very high efficiency, high cost. Slipping here is no, because it is positive drive, and then heavy. Now let us quickly move on to the gears. So here is what the original topic starts. Gears are toothed wheels. It has tooths. You can see in this picture that here tooths are built on this. So here this is a simple thing, and on it some tooths are built, which is used for transmission of motion and power from one shaft to another. So this is shaft number 1 here, this is 2, this is 3, this is 4. Rotation of the shaft 1 creates rotation of shaft 2, which in turn rotates shaft 3 and on turn 4. So here we see that there is transmission of motion and power. Gears are used when the center distance between shaft axis is small, and they provide positive drive. Why? It is a very good interview question. Why it is a positive drive? Because there is no slippage. Okay. Next, if we see the classification of gears, then we can classify them into parallel shafts, intersecting shafts, non-parallel shafts, and non-intersecting shafts. Remember, it is very much important topic. So whenever we come to parallel shafts, remember that the axis of rotation are parallel to each other. Okay, this is parallel shaft. So parallel shaft can be classified into spur gear, into helical gear, or we can write single helical. We will see each of them, and into double helical. Okay. Next, when we see intersecting shaft means they will intersect at a point. This is shaft 1 and this is shaft 2. They will intersect at a point, but parallel shafts will not intersect. It will be bevel gear. Okay. Bevel gear are of further two types: straight bevel and spiral bevel. And there is another type of shaft which are non-intersecting, means they do not intersect with each other and they are neither parallel. So for example, like the worm gear, worm and worm wheel. Okay, then there are hypoid. We will learn about all of this one by one with animation. See, this is the spur gear. Before looking into the animation, here first look into the topic, then we will go into the animation, right? Here the teeth are straight and parallel to shaft. See, this is the shaft. Now if this is the wheel, it will have straight teeth parallel to the shaft. Okay, here we see this is the shaft. Here we can build a shaft, and these are all parallel, right? These are all my teeth. Next, most simple and common type and used for low to moderate speed. Here we use this for low to moderate speed. We cannot use it for high speed because the entire load is on a single teeth. Okay, whenever we see the meshing here of these gears, then entire load is in the single teeth. You can see how this teeth comes in contact, only one teeth. So we cannot use, this is gear 1, gear 2. Only one teeth of the second gear comes in contact with the first teeth. So we can't use it for higher load. It is simple construction, easy to manufacture, high efficiency, low cost, easy maintenance. But at high speed it is very noisy because there is a direct line contact and it is not suitable for high speed application, and there is sudden load on the teeth. But in small gearboxes, in machine tools, in conveyors, clocks and printing machines, we use this spur gear. See this animation from a larger point of view. You can see how the engagement is in a single. Let me just pause this video so you can find it here, that only a single teeth here, this teeth of the second gear. Okay, these I have drawn the teeth of the second gear, or the pinion we can say, and here this is the teeth. Maybe I can just highlight it a bit. Okay, so now this is the, so we can see that there is very less contact. Here it is only in contact with this one. So you can see complete load comes in only one teeth. So it is not useful. Now there is another improved version, which is the single helical gear. Here we saw that in the previous example, in spur gear we have the teeth parallel to the shaft. Okay, so this is the shaft and these are the teeth parallel. But in helical gear they are at some angle. Either they are left angle or they are right angled. Okay, so this is the construction. So they are not parallel and they are inclined. The teeth are inclined to the axis of the shaft. So if this is the axis, this is the axis of this, these are inclined at some angle, right? It makes some inclination angle. Now it can be left hand or right hand, and it provides smoother operation. Why smoother operation? Because we can see that these get contacted from a single point and then its point of contact increases. No, there is no direct straight contact on one teeth, but multiple teeth are engaged. These are smooth and quiet operation. These are higher load carrying capacity, suitable for high speed, less vibration. But the disadvantage is that axial thrust is produced in the direction of motion. Okay, so on the axis there is a thrust. Whenever these are at angle, remember, whenever these are at angle, okay, they are merging at a point, so the actual thrust will be applicable at a single point, so there will be axial thrust. Its efficiency is less than this spur gear. It is costly and it requires thrust bearing. Why thrust bearings are required? To accommodate this axial thrust. Okay, so it has provided a large amount of axial thrust to accommodate this, and so that the motor doesn't damage, we require the thrust bearings. Applications are automobile gearboxes, compressors, turbines, and industrial machinery. Next, improved version of the helical gear is the herringbone gear. Here remember, if this is the gear and this is my shaft, then teeth are generally, both the left and right hand teeth are present in the same gear. Okay, so this is the herringbone gear. So what advantage does it have? In spiral, in the single helical gear, we saw that there is axial thrust, but in this, the motion, what this does, it cancels the axial thrust on single direction, since it provides a thrust this side and this side, which cancels it. Okay, next, it eliminates axial thrust and combination. We have learned this. Advantages are no axial thrust, smooth and silent operation, higher power transmission. But it has disadvantage, higher cost. As we increase the complexity, there is a higher cost and there is limited load carrying capacity. But these are used in heavy duty gearboxes, marine engines, and rolling mills. Now let us move on to the next topic, that is gears for intercepting shafts. We know this is shaft 1, this is shaft 2. First is straight toothed bevel gear. See, how does this image look from the front side or the top side? These are all straight. Okay, all pointing towards a single point. So this you can see, let me draw it with a different color. This and this points and this. You can see that if this is the shaft axis of 1, this is the shaft axis 2, they are intersecting at a point. Therefore, these are known as the gears for intersecting shaft. This is straight tooth, and bevel gear means it is 90 degree. Okay, the shafts are at 90 degree. This is shaft 1 is in 90 degree with shaft 2. Now, simple design, efficient power transmission, and it is noisy. Whenever we come with straight gears, it's noisy generally because of a single point of contact, or we can see say a single tooth contact, right? Next, application. It is used in differential gears. It is used as machine tools. Next, to modify it and to accommodate a larger load carrying capacity, to accommodate a silent operation, what we did, these single teeth gears are now made bit spiraled. Okay, we have just spiraled them. Okay, now this is the second pinion, we have just spiraled them. These are both the shaft, and they are still at a 90 degree point of intersection, but these are spiral shaft. You can see the image here. There are smoother operation than straight bevel gear, and quieter operation, higher load capacity, smooth power transmission, but it is much costly and it is very sensitive to misalignment. A little bit of misalignment can damage the whole system, right? It is used in automobile differentials. Remember, whenever there are trucks or in the differential gearboxes, we use these type of bearing. See, this is the from the steering, it is coming here, and from this to the wheels. So at 90 degree the power is transmitted. Okay, so if we see the truck, image of the truck here. Okay, for example, let us take this vehicle here. Now here is the motor, and it is transmitting, it is rotating the shaft here. Here there is a bevel gear, here another bevel gear, and these are transmitting to two wheels. So at 90 degree you can see the transmission is there, and therefore in automobile differentials this type of gears are used in helicopter drives and also in heavy machinery. Next, the important one is gears for non-parallel and non-intersecting shafts. So when shafts are skewed, so they are either at angle, they are not 90 degree, or the gears are means you can say that they are not 90 degree or not parallel. Examples are worm gear, spiral gear, hyper gear. Spiral gear, as you may see, say that the spiral gear is similar to this construction. Okay, but the only differences is that here the shafts are parallel, and what happens, the shafts are parallel here, but in this type of gear they are not parallel. If we draw a 30 degree if I draw image of it, let me just find a page here. Okay, so what happens in spiral angle, spiral gears. So this is my first gear, this is the shaft. Let me draw a better one. Okay, so here these are all spirals. I'm just trying to draw a 3D one. See, whenever we come to okay, this is something, this is what we have learned in the spiral gear, right? Just a minute. This is the image of the helical gear, right? This is the helical gear, a simple helical gear. But in spiral gear, see, these are parallel shafts, but here these are not parallel. You can find it like this. These are same, I have drawn the same gear here, this shaft, and this is at some other angle. This might be at this angle. So you can see wherever the shaft is coming in this direction, but this shaft is not parallel to it. So you can see that both the axis of the shafts, in case of helical gear, they are parallel with each other, but in spiral gear the shafts are at different angle. This is the only difference, okay, between the helical gear and the spiral gear. I don't have the exact module of the spiral gear, therefore I have just made you understand like this. So now let us move on to the worm and worm wheel gear. It consists of worm or a screw. So this is the worm, right, and a worm wheel. So what happens, remember why this one is used. First, it does large speed reduction in one stage. We will learn what is one stage, but remember here only thing that in one stage we are transmitting with only one gear and one pinion. This is the actual thing of one stage. Okay, now what are the advantages of it? The advantages of it are, it is a compact design and it is self-locking possible. Due to the self-locking possibility of self-locking, these are used in lifts and elevators. These are used for steering mechanism, and this is quiet operation, low efficiency. They have low efficiency and a heat generation, but due to self-locking possibility and large speed reduction, these are used. Whenever you notice that whenever this is moving at a high speed, okay, whenever this is moving at a high speed, you can see this due to the worm wheel moves at a very slower speed. Okay, due to the large number of large dia and small dia of this, let me make you understand this. There is a small dia of the worm, right, and a large dia of the wheel. So a larger movement, one circular rotation will create movement, a little bit of movement here, then 2 3 4 5 movements will finally lead to a very small movement in the worm wheel, right? So movement of these, if you see in some applications like in lifts and elevators, then you can find that the motor is rotating at a very high speed, okay, but the movement of the lift is very slow, and due to this self-locking, these are used. Next, in hypoid gear, this is similar to the bevel gear, but remember in bevel gear, what was the operation? Okay, what was the operation? The operation was that these are intersecting shafts, okay, and these were all connected similarly. But here what they have changed is they are now not intersecting. See, they are not intersecting, and the connection is also at some different point. So its shaft is here. Its shaft is here. If we move this in the front direction, then we can see if this is the first wheel, so this is attached here. We can see that both are not intersecting. This is the front view. If this is the front view, then we will move to the side view. So we can say that it is attached to only one side of the gear. So here it is attached to only one side and not the center. So both of them are not intersecting. And the advantage is smooth and quiet operation, high torque transmission. Remember that here there is high torque transmission, and a larger amount of torque is transmitted due to the larger point of contact, higher contact stress is generated, complex manufacturing, and the applications are automobile, rear quick differentials, and heavy vehicles. Now moving up to the gearbox. What is a gearbox? Whenever we come to the gearbox, remember that it's defined similarly to gears. Okay, in gears we are talking about a single gear, but in gearbox we talk about a larger unit, right? But there is a main difference which we will look into in the next topic. See, a gearbox is a mechanical device used to transmit power and change speed and torque. What we learned in the gears. A stage of gearbox refer to one pair of meshing gears used to transmit motion. Here we learned about the stage of the gearbox. Whenever there is a one pair of meshing gear, we call it a stage. In two stages, there will be two pairs of meshing gear. In three stages, there will be three pairs of meshing gears. For example, let me draw a top view here. This is a gear and this is another gear, right? So here it is one pair means two. So one gear, one pinion. So this makes a pair. So it is single stage. Now when we talk about two stages, we will say this is a gear here. Okay. Next. This is my second gear. And on the same shaft, I have another gear here. Next, I have another gear here. So see, first gear is in contact with second gear. So this is one pair, this is two pair. So this is two pair. First one pair, two pair, and then three or above we say it is multi-gearbox or multi-stage gearbox, right? Each stage provides a certain speed reduction or increase. So when does the speed increase? Whenever the bigger gear rotates a smaller gear, the speed will increase, because one rotation of width of one will create a larger rotation of the small one. Okay, imagine it. So whenever there is a smaller gear, it is rotating a bigger gear. You can see that the speed of we know a formula that N1 by N2 is equal to T2 by T1. This is the speed reduction formula. Okay, so the higher the speed, the lower will be the teeth. So in case of if N1 is the higher speed, then the speed divided by N2, and let the number of teeth be T1 and this be T2. Okay, so N1 by N2 speed, N1 by N2 is equal to T2 by T1. Remember, from where does this formula come? This formula comes from pi D1 pi D1 N1 is equal to pi d2 N2 from this, and we know the diameter can be reduced into teeth pi. So from this, all of these constant cancel out, and pi d1 pi also cancel out. D1 N1 is equal to D2 T2. So we can say the diameter of 1 by diameter of 2 is equal to N2 by N1. So with increase in the RPM or the speed, we can say if N1 is moving with a higher speed, then it's D1 or the diameter of the teeth must be, but we can say if N2, let us suppose that RPM, let me make a new slide here. This slide has already existed. For example, let us N1 is equal to 50, D1 is equal to 100, N2 is equal to 25, then find out D2. Okay, now from this example we will see N1 has a higher speed, N2 has a lower speed. So we know the formula N1 by N2 is equal to D1 by D2 by D1. Okay, so N1 is equal to 50 by 25, D2 is equal to, we have to find out, and here it is 100. So 25 into 2, so 200 is equal to D2. So now we see whenever the speed is equal to speed is high, the diameter of this is small. As if the speed is less of the second gear, the diameter is larger. So we can see its construction can be said like this: N1, N2. Here we can see it has number of teeth. Here the number of teeth is 200, or the dia is 200. In this case, the dia is 100. Okay, this we are talking about dia. Do not confuse it with the teeth. So in this case, N1 is moving at a high speed. You can see with 50 RPM, and number of teeth are less, or the dia is less. N2 is moving at a slower speed. Its D2 is equal to 200, that is, its dia is more. From this we can conclude that each stage the reduction or increase can be done by the increasing the dia or the number of teeth. Now whenever we come to the gearbox, remember that it is a protected outer covering that encloses all gearbox components. It supports the gears, shafts, bearings, lubricants. So this is a simple image of a gearbox. How many stages is it? Can you just say? See, if we come to this stage, we will learn that stage of gearbox, when one pair of meshing gears is used for transmission of gearbox, is called a stage. See, this you can see, this is for gear number 1. It is meshing with gear 2 or the gear 1, gear 2. I am not expressing your opinion to avoid confusion right now. Okay, so it is single stage. Now you can see that this gear is meshing with this one, so we can say it is 2. So this is a 2-stage gearbox, right? So for 2-stage gearbox, for 1-stage gearbox, remember, for 2-stage gearbox you can see that the number of bearing points in the gearbox are +1, stage +1, because in this the number of shafts will be, in 1-stage gearbox there are 2 shafts, in 2-stage gearbox there are 3 shafts, in 3-stage gearbox there will be 4 shafts. So the number of shafts will be equal to number of stages of gearbox, or the stage of gearbox, +1. Remember, this is a very important thing asked on the interviews. Next, what is the need of the multiple stages? For larger speed reduction required for single gear, and single gear pair cannot provide very high reduction. We cannot use the worm and worm wheel everywhere to reduce in a single stage. To reduce the size of gears, a multiple stage is done. To improve the efficiency and distribute the load evenly, a multi-stage is used. Now here we can see that for this type of gearbox, what you are using here, it houses the bearing. So this is the bearing, these you can see are the bearings. It houses the shafts, it houses the gears, okay, and also the lubricant. The function of gearbox casing are, it protects the gears and shaft from dust, dirt and moisture. To avoid lubrication contamination, it also prevents its leakage. It supports and also provides alignment to maintain the proper alignment of gears and shafts. For noise reduction also, gearbox are used for safety and to prevent accidental contact with moving parts. For heat dissipation, that is for heat dissipation through the gearboxes, from wherever the heat is generated inside by the meshing of the gears, it is transmitted to the gearbox. So by this it uses heat, it provides heat dissipation. Now see, if for this multi-stage gearboxes, if there is single stage, the speed reduction is very less, cost is also less, and its complexity is simple. For as we increase the stage to multi, here the speed reduction is high, the cost is high, and complexity is also high. Now let us see what is the speed ratio. The speed ratio is defined as the ratio of number of teeth on driven output. Okay, what we have learned here, N1, N2. It is the number of teeth on output gear. For let us consider this is my input gear and this is my output. So speed ratio, we will say it's number of teeth on output gear. Let it be T2 divided by T1, and speed ratio is equal to N1 by N2. So this is the formula that we have learned. Next, the output speed will be equal to, what we can say that output speed N2 will be equal to input speed, that is N1 divided by speed ratio. Okay, divided by speed ratio. Speed ratio can be termed as T2 by T1. So here we can write T2 by T1, or T1 comes above. So this is the formula. And remember, if I provide a question here, if the input speed, let me provide a question, if the input speed N1 is equal to 100 and speed ratio is equal to 2:1, then find the output speed, or N2. So find it. This will be the homework for you, because the formula has been given in this slide. You can just pause it and use it. So the input speed is 100, the speed ratio is 2:1, find the output speed. This is the question. So for in-depth course is available at esparks.in, and this has been association with Esparks. There is a course we have designed with the gear and gearboxes for power transmission systems. This is specially designed for mechanical engineers. You can now enroll for it, for industrial professionals, students, and for interview preparations. So the website, let me mention, it is esparks.in. Here we have started with the machines, then gearboxes. We have gone into detail of the gearboxes. We have covered the applications of all of these spurs, gears and all. Next we have also covered gear trains. We have covered the formulas, the nomenclature of these, okay, and the condition monitoring of gearboxes, the we can say the overhauling of gearboxes. Okay, so these all are available in this course. You may go to esparks.in. Here you can visit the courses tab provided above and or search for it, and then you will find gear and gearboxes course. You can purchase it. Thank you for being here, and if you want to support it, then support us, then please you can provide support on the provided link. You can also provide support if you don't want to provide monetary support. You can like our video, subscribe to our channel. Thank you.